Hello, students. I can't make it to class today, so I'm giving you this lesson via a recording on YouTube. So today I'd like to review with you how to convert between the different forms of quadratics. So there are three different forms of quadratics. You have typically seen something called the standard form. So on your screen there you see y is equal to x squared plus 4x plus 3. That's not the only form of a quadratic, the shape or the sort of the format that it appears in. There's actually other forms. So an example would be the vertex form. Vertex form is a very popular form because it tells you what the vertex of the parabola is, the tip, the highest point, or the lowest point. There's also the factored form or the intercept form of a parabola. You've been working a lot with that one recently. So you could go, for example, from standard form to intercept form. That's what factoring is. It's taking a quadratic in standard form and it's doing a little bit of manipulation and getting that quadratic into factored form. That's what factoring is. For example, finding two numbers that multiply to 3 but that add up to 4. In this case, that would be 3 and 1. 3 times 1 is 3 and 3 plus 1 is 4. That's why we got that x plus 1 times x plus 3 at the bottom down there. Today you're going to learn how to convert from standard form to vertex form. The vertex form here you see in your picture right here. Let me change the color of my pencil. It's this here. That's what vertex form is. And the reason why we call it vertex form is because you can read the vertex right off of the graph, right off of the parabola. The vertex here is -2, -1. You're probably wondering, well, where did that -2 come from? That +2, you're always going to switch the sign. So if you see a -4 there, you would say that would be 4. If you saw a +6, you would say that there's a -6 there. So you just flip the sign. So the vertex here of that parabola is the point -2, -1. So the reason why this is important is because the different forms give you different information about the parabola. And once you have all the information about the parabola, once you know its vertex, once you know its x-intercepts, once you know its y-intercept, you can do a pretty good job at graphing that parabola. So for the parabola you're looking at on your screen now, this parabola here, even though it looks different from this parabola here and this parabola here, they're exactly the same parabola. They're just expressed three different ways. The first way, you can easily read the y-intercept from the graph, and from the formula, and that is the number right here, the constant term. So the y-intercept here is going to be 0, 3. Now from the factored form, which you get by factoring a quadratic, you can read the x-intercepts, and the x-intercepts here are -1 and -3. Now, the way you would write that would be -1, 0 and -3, 0. Those are the 2 points of the graph. X -1, y 0, x -3, y 0. And what that means basically is if you plug the number -1 into this equation, you're going to get a value of 0 because -1 plus 1 is 0, and no matter what the x plus 3 is, 0 is going to wipe it out. So you're going to have your y value is going to be equal to 0 here. So that's what you can read from the factored form. Now what you can read from the vertex form is, as I mentioned on the previous slide, you can read the vertex of the parabola. You can read the tip of it. So the tip here would be -2, -1. So notice how we have 4 separate points from looking at these three different forms. I'm going to try to highlight this with my highlighter pen. We have this point, 0, 3. We have this point, -1, 0. We have this point, -3, 0. And we have this point down here, -2, -1. So there are 4 different points there. You can take those 4 points, plot them on a graph, and connect them with a parabola curve, either a parabola curve that opens up or a parabola curve that opens down. And you know the difference between the two. When something is opening up, the value in front of the x squared term is going to be positive. If something is opening down, the value in front of the x squared term is going to be negative. That's how you tell whether something opens up or down. So today, you're going to learn how to convert from the standard form to the vertex form. This technique is called completing the square. And I'm going to show you that technique right now. So please write this down in your notes so you can do this yourself for different parabolas. So I'm going to convert the parabola that's on the left to the parabola that's on the right. So y is equal to x squared plus 4x plus 3. I'm telling you, if I type that into a Desmos, it would look exactly the same as were I to type in y is equal to x plus 2 squared minus 1. You couldn't tell the difference between the two of them. Here's how to go from the one on the left to the one on the right. There's a couple of little mechanical steps here that you need to be aware of, and just execute them slowly. Take 1/2 of the middle term. So I'm going to do 1/2 times 4, the coefficient of the middle term. 1/2 of 4. That's going to give me the number 2. Now I'm going to square that 2. I'm going to do 2 squared. And that's going to give me 4. Now that 4, I'm going to add and subtract that 4 to the standard form. So I'm going to write it this way. Y is equal to x squared plus 4x plus 4 minus 4 plus 3. Now notice what I did there. This plus 4 and this minus 4 are simply 0. I didn't change the quadratic in any way. I just put a very creative 0 in there. So those are the standard form. Y is equal to x squared plus 4x plus 3, and y is equal to x squared plus 4x plus 4 minus 4 plus 3 are the same exact things. But now, because I've done this, because I've added this creative 0 here, I have a perfect square on those first 3 terms. These first 3 terms right here are a perfect square. If you factored that, you'd get x plus 2 squared. And the reason why I get x plus 2 squared, I get this. Because this number here, I simply put that number right down here. Put it right down there. Do x plus that number, or if it was a minus, it would be x minus that number, squared. You'll notice if you tried to factor x squared plus 4x plus 4, you're looking for 2 numbers which multiply to 2 and add up to 4. That's going to be 2 and 2. So it's going to be x plus 2 and x plus 2, which is x plus 2 squared. So now I still have that minus 4 plus 3. I've got to clean that up. So minus 4 plus 3, as you know, would be negative 1. So notice how what I just created here is exactly the same as what I told you I would create. The equation over here is exactly the same as this equation. That is completing the square. Let me move my screen up here a little bit. I'm concerned you might not have seen that at the bottom there. My apologies. So the way you complete the square, you take the coefficient of the middle term, you take 1/2 of it. This is what we did right here. Then that number that you got when you took the 1/2 of it, we got a 2, you square it to get 4. In this case, to get 4. Then you add and subtract that number 4. And once you do that, the first 3 terms, the first 3 pieces of that polynomial will be a perfect square. And you can write that perfect square in this way, using that number 2 that we got when we took 1/2 of 4. And then you clean up this piece here, the plus 4 and whatever the constant term is there. Like, I'm sorry, the minus 4 and whatever the constant term is. The minus 4 plus 3, and that gives us minus 1. So that's your first example. I'm going to do 3 more. And I've pre-prepared the 3 for you here. I'm going to create the vertex form of each one of these parabolas. Take 1/2 of 7, and you get 7 over 2. Then square the 7 over 2. And here I get 49 over 4. So I'm going to take the two numbers that, I'm going to take the number that I just built and add it and subtract it to the parabola. X squared plus 7x plus 49 over 4 minus 49 over 4 plus 6. Now, this is going to be a perfect square on the left-hand side. It's going to be x plus 7 over 2 minus 49 over 4 plus 6. Notice how I took these three and these became the perfect square. This 7 over 2 right here came from right there. Now I can clean that up at the bottom there. The 49 over 4 plus 6, I can express 6 as 24 over 4. So we can write this as minus 49 over 4 plus 24 over 4, and this just remains x plus 7 over 2 squared. And cleaning this up a little further, negative 49 plus 24 would be negative 25 over 4, I believe. And we get x plus 7 over 2 squared. Let me move this out of the way here so you can see the bottom portion of the screen. So this parabola right here and this parabola right here are identical. They look very, very, very different. Let's see if they're exactly the same. Let's open up our friend Desmos. I'm not asking you to do this on your computer right now. I'm just going to test out to see if we got this right. X squared plus 7x plus 6. Y is equal to x squared plus 7x plus 6. Looking pretty good. And now I'm going to put right next to it, I'm going to put our brand new vertex parabola. X plus 7 over 2 squared minus 25 over 4. I admit it looks pretty creepy with all those fractions, but you've got this. You can handle these fractions. Y is equal to, open parentheses, x plus 7 over 2 squared minus 25 over 4. And sure enough, that parabola, which is the color blue here on the screen, just sits right on top of the red parabola right above it. Now, this parabola looks pretty simple. You can read the y-intercept from it. There it is right there, 0, 6. You can see it number right there. Just, it's that number 6. Now this here, this looks pretty ugly, 7 over 2 and 25 over 4. However, that is what the vertex is of this parabola. Negative 7 over 2, comma, negative 25 over 4. I want to write that here just for a moment so you can see it. The vertex here is this. 7 over 2, sorry, minus 7 over 2, comma, negative 25 over 4. And 7 over 2 is, what, 3.5? So if we go back to this graphing calculator, this should be about 3.5. 2, 3, 4, 3.5 is right here. Perfect. And that y value down there, negative 6.25, that's exactly what negative 25 over 4 is. So we completed the square, and we figured out what the vertex of the parabola was by completing the square. Now, let's just go review those steps one more time. We took 1/2 of 7. We got 7 over 2. We squared the 7 over 2, which gave us 49 over 4. We added 49 over 4, and we subtracted 49 over 4, which just added a 0 to the quadratic, which didn't change it. Then we made a perfect square because that's what completing the square automatically does. It automatically gives you this perfect square right here. Change my highlighter. It gives you this perfect square right here. It does that because you've built a perfect square trinomial here by adding this very creative value onto the end of it. And then we cleaned up and we got our final answer, which is the vertex form. And we read the vertex off it, and there's the vertex. So I'm going to make a copy of this slide because I think I spilled over a little bit to the right here, so I need a little bit more room. Duplicate it and then move over to the next slide here. Oh, and the room light just went out. Walk around for a second here. It's very late at Oceana right now, so I think it's about 10:19, so your math teacher is here in the creepy hours of the morning. So, I'm sorry, the creepy hours of the evening. Back to school night just finished, so I'm on campus here extra late. So I'm going to remove this stuff from this slide and do the next parabola. Now we're going to complete the square on the second parabola, x squared plus 4x minus 32. Same exact technique we did on the previous slide. Same technique. I'm going to take 1/2 of 4, and that is going to give us the number 2. We're going to square 2. That's going to give us 4. We're going to add and subtract the number 4. X squared plus 4x plus 4 minus 32. Now we're going to make a perfect square trinomial. We're going to convert the perfect square trinomial into a perfect square. We're going to write x plus 2 squared just by taking that number 2 right there and dropping it right down here. And we're going to add together whatever the leftover constants are. Minus 4 minus 32, which would be minus 36. So that is your vertex form of x squared plus 4x minus 32. X plus 2 squared minus 36. And you can read the vertex off of that, I bet. -2, 36. I'm sorry, negative 36. -2, negative 36. Even I sometimes forget to switch the sign on that 2 there. That would be the vertex right here. So I'm going to do one more and move all this stuff out of the way here. The last one, the last example, I'm going to take 1/2 of -3, and that's going to give me -3 over 2. I'm going to square -3 over 2. -3 over 2 squared is equal to 9 over 4. I'm going to add and subtract 9 over 4. X squared minus 3x plus 9 over 4 minus 9 over 4 minus 10, which is what's left over. Now I'm going to make a perfect square out of the first 3 terms by taking that piece up here, x minus this -3 over 2, and I'm going to go x minus 3 over 2 squared minus 9 over 4 plus 10. And then I'm going to add together the minus 9 over 4 plus 10, and I believe that would be -9 over 4 plus 40 over 4, right? Because 40 over 4 is equal to 10. And that would be that'd be positive 31. So that would be 31 over 4, and we bring over the part that I have that I didn't carry down here. X minus 3 over 2 squared plus 31 over 4. So that is your vertex form of x squared minus 3x minus 10. And the vertex here, I think you can read it, positive 3 over 2, comma, 31 over 4. So just to write that down so you can see it, it would be, I'm going to put an arrow over here. I don't have much room in the lower right-hand corner. Maybe I can do it in the lower right-hand corner. The vertex would be 3 over 2, comma, 31 over 4. That would be the vertex of this parabola. So because you have the vertex, and because you have the x-intercepts, and because you have the y-intercept from the 3 different forms, you can graph that parabola. Just put a point right by the vertex, put a point by the 2 x-intercepts, and put a point by the y-intercept, and connect all of them with a curve, with a parabolic curve. And that is how to complete the square. You've got a set of questions on your quadratics practice for today. And the practice, there are 1, 2, 3, 4, 5, 6 of these. I'd like you to complete the square on the 6 of these. Now, the other part of the assignment should be self-explanatory. I think you know how to factor quadratics. I'd like you to factor these 12, or there are 14. I'd like you to factor these 14 and do the additional, answer the additional questions on page 1 and 2. I hope you find the video helpful, and I'll see you when I return. Thank you.